Hi folks, here we go. This is chapter 1.3, all about lines. And I hope today it will be a little faster than last time. I expect it will be, because I think last section was pretty long, but this one's a lot easier and there's less problems too. Only 14. Although 14 sounds like a lot, but it's really not too bad, I think. Because the first questions are just about calculating the slope between 2 points. So let's talk about what we're learning today. Calculating the slope between 2 points, and then recognize the slope of a line by looking at a graph. Those two things together, pretty easy and fast, I think. And the next is constructing the equation of a line. So we're gonna do that one along with graphing linear equations together. So hopefully we'll finish in 3 videos this time. And then the last thing that we're learning is understanding parallel and perpendicular slopes and how to calculate them. Okay, so let's start with topic number 1. That's the focus of this video. Topics 1 and 2. First, calculating the slope between 2 points. And it's pretty easy. All you do is you divide the up and down distance. And up and down distance you can get by subtracting y2 minus y1. They say y2 minus y1 because we kind of think of y2 as being sort of like the second point, right? Or like the right-hand point maybe. But it doesn't really have to be on the right. It doesn't even have to be the second point. As long as you're consistent. Because, when you're labeling your points, you could have just switched their names and made the first point y2 and x2, x2, y2, right? So it really actually doesn't matter. That's why what we'll see later is when you calculate slope, you can actually go in the other direction if you want to, as long as you're consistent. So anyways, you divide the up and down distance y2 minus y1 divided by the horizontal distance x2 minus x1. And that's all this equation says here. Don't be intimidated by all that mathy language, the letters. It's just telling you the slope, m for like mountain slope. I don't know why they didn't use s, but I guess maybe because s was taken already. I don't know. So the slope is the rise divided by the run, which you probably remember from middle school days, right? Another way to write the rise over run is delta y. Anytime you see a delta, it stands for the change. So it's a change in y divided by the change in x. And all this is just different ways to say the exact same thing. The change in y is what we said earlier, the difference between y2 and y1. The change in x is the difference between x2 and x1. That's the horizontal distance. Or equivalently, like this is what I was alluding to earlier, I could switch it around and do y1 minus y2. And that's totally fine because you get the same end result as long as the bottom also matches. So you do x1 minus x2. What you do need to be careful of is don't mix up these two things. So don't say y2 minus y1 over x1 minus x2, because that will mess you all up. You're going to get the opposite. You're going to get a negative of what your real slope is. So as long as you're consistent, y2 always first, or y2 always second, x2 always second, then you're going to be fine with the slope. Okay, that's how you calculate the slope. And then once you have the slope, you can, you can plot the point. You can plot a graph pretty easily. When we're looking at a line, let's say we already graphed the line, and you want to go back and figure out what the slope was. Well, you just kind of go in reverse, and you look at the rise over the run. That's the second topic, right? Recognizing the slope of a line by looking at the graph. And to do that, you just look at your 2 points on the line and try to figure out what is the rise between those 2 points, what is the run between those 2 points. The division of those two things will give you the slope. All right, let's go to the questions now. And I just realized, this is a case where I should be working on a grid because we're doing a lot of graphing here. So let me start a new page with grid lines. All right, number 1 first. So to start with, let's find the slope. So let's pick, this will be x1, this will be x2. It's a little bigger. And then let's say this would be y1, that would be y2. So the slope is, remember, y2 minus y1, or equivalently. You can switch it, but let's just stick to the 2 and then the 1. Okay, so because that's kind of the typical way you see it. So y2 in this case would be the 5, right? and 5 minus y1, which is 3, over x2, which is 4, minus x1, which is negative 2. Negatives, you keep it in parentheses so we don't mix up the signs. 5 minus 3 is 2. 4 minus negative 2 is 4 plus 2, so that's 6. So you have 2/6, but then we can reduce that to 1/3. All right, so the slope is 1/3. Now that's the first half of the question. The second half was to plot the thing and graph it. Easiest way, since we're already given 2 points, let's just plot these 2 points and then connect the dots. That will give us our graph. So, let's try to draw it on the lines. Okay, and then we want negative 2 comma 3. So negative 1, 2 comma 1, 2, 3 right there. And then we have 4, 5. So 1, 2, 3, 4 comma 1, 2, 3. Oh, I'm sorry. Should be writing on the line. 1, 2, 3, 4, 5 right there. So about there. And then I just want to connect these 2 dots. Okay, so now so that's our graph over line. And now we just want to confirm that the slope is indeed 1/3. So how do I do that? Let's just pick 2 points on our graph. Let's see. I guess let's start with this point that we already have. And then let's check if I go 1 up and 1, 2, 3 over. Am I going to land on my line? And yes, I do. Right. The rise is 1. And then the run is 1, 2, 3. So yeah, that's 1 and that's 3. So perfect. That's it. Question number 1 done. And the rest of the questions, are they going to be the same thing? Okay. I don't think I was able to copy just a portion. I tried that before, but see if it works. So yeah, it just wants to copy the whole entire thing. So I guess what I'll do is let me go back to the original. I'll just do them one at a time now, which is what I should have done from the beginning. Okay, so here's question number 2. So same exact procedure. By the time we do this 4 times, we should have the procedure down pretty well. So we want the slope first. Look a little thicker pen today. Slope first, which is y2 minus y1 over x2 minus x1. So here's x1, x2, y1, and a y2. That's going to be 3 minus 2 over 5 minus 1. No, even easier than the first one. 3 minus 2 is 1, 5 minus 1 is 4. So 1/4. All right, let's go to plot this thing. Okay, forgot to label my axes last time. Sorry, that's x and y. 1, comma 2. So from first point. And then 1, 2, 3, 4, 5, comma negative 1, 2, 3 is my second point. So right there in the middle of that square. All right, and then I connect my dots. Ooh, it's kind of off there. Let's try to do a little more close to the points. Okay, something like that. Yeah. And then let's confirm our slope now. The slope is supposed to be 1/4. So I think I made a mistake somewhere because that does not look correct. Oh, I see where I went wrong. Sorry, guys. So this is good practice of noticing my errors. So here is an error. This was supposed to be a -3. Sorry, you must have been screaming at the screen watching that earlier. That's a -3. So that would have made a -3 minus 2 is negative. Let's erase this. -5. -5 over 4. Yeah, sorry about that. Okay, so let's check our slope now. It's a good thing we're checking, right? Because now we caught our mistake. So -5 means 5 down, right? Let's check from our starting position. 1, 2, 3, 4, 5 down, and then 4 over. So 1, 2, 3, 4 over. And yep, that's 4, that's 5. So slope is -5 over 4. That's correct. One more small comment about the negatives and positives, guys. So in this case, I chose to use the negative as the up and down, but you can actually stick the negative either side on the top or bottom. Just pick one or the other. And we know from just basic algebra that whether negatives on top, the bottom, or even in the middle, it's all means the same thing. So when you practice for plotting a slope though, just pick either the top or bottom. So just now I picked the top. What if I was to pick the bottom and say 5 over -4? So what would that look like? That would be like going up 5, 1, 2, 3, 4, 5, right? And then to the left 4, -4 in the run would be to the left, right? So 1, 2, 3, 4. That would put me right in the middle of that box here. Now let's confirm if I extend this line here. Does that match up? And yeah, that matches up, right? So either way, you would end up in the same line. Okay. Next question, number 3. Okay, here we go. Number 3, what color shall we use this time? How about this green and blue? So same thing, x1, y1, x2, y2. My slope is gonna be 3. I skipped the first step, yeah, let me just write it down. y2 minus y1 over x2 minus x1. y2 is 3 minus, side note guys, when you're doing a test or something, it's helpful to write this down because let's say you mess up everything else after that. Let's say you write the wrong numbers here. If you at least had written this down, I could give you some pity points or some partial credit. So just remember to do that kind of thing. Okay, 3 minus 3 in the top. Oh, interesting. Okay. The bottom is going to be 1 minus -2. But it doesn't matter because the top 3 minus 3 is 0. 1 minus -2, that's 3, but it's not important because... sorry, I forgot my parentheses. I was preaching always put the negatives in parentheses. I forgot to do it. Okay, 1 plus 2 is 3. But it doesn't matter what's in the bottom because 0 divided by 3 is just 0. So the slope is 0. And that means when I go to a graph, I should expect a horizontal line. Slope 0 means the horizontal line. Slope that's undefined when you're dividing by 0, that's when you get the vertical lines. Okay, x-axis, y-axis. Let's plot our 2 points. -1, 2, comma, 1, 2, 3, right there. Oops. I'm supposed to be doing that on the axis, yeah. Okay, and then 1, comma, 1, 2, 3, right there. So you connect the dots. Here, there's not much to discuss for the rise over run. Rise is clearly no rise from here to here. The run, you can pick any 2 points, you get a different run. In this case, I have 3, so the rise would be 0. The run would be 3 for a slope of 0. All right, one more question. I wonder if this one will be a vertical line. And yes, it is. It is vertical because I see the first 2 values are the same. Okay. Let's go back to black. Back to black. Okay, so here's x1, y1, x2, y2. Slope is y2 minus y1 over x2 minus x1. y2 is 1, y1 is 3, x2 is 4, x1 is 4. So I have -2 over 0, which is undefined. You cannot divide by 0, not possible, so we say it's undefined. So sloping undefined means that you got a vertical line, and it's strictly speaking, the slope is not a number. Let's go to graph this thing. x-axis, y-axis. And my points are 1, 2, 3, 4, comma, 1, 2, 3. Oh, I'll keep doing that. 1, 2, 3, here. And then 4, comma 1. 1, 2, 3, 4, comma 1 is right here. So connecting the dots, indeed I have a vertical line. Now I'm going to check the rise over run. Rise, I can go as much as I want between any 2 points. If I pick these 2 particular points, the rise here would be 2, right? But what is the run? Well, I didn't go left or right, so it's 0. So the rise would be 2 over 0. The rise over run is 2 over 0, which is still undefined. Just looking at the thing, if I have a vertical line, I go straight to being undefined. Whereas if I have a horizontal line, I go straight to slope being 0. All right, guys, that's video 1 out of 3, I believe. I think we'll finish in 3. See you in the next one.